time. When you're diving, sometimes there just isn't enough of it. Somehow it seems like the better the dive, the sooner it ends. Much of diving's evolution has been a struggle for more time underwater. We use better and more effective exposure suits to help us stay comfortable longer. Dive computers give us far more no-stop dive time compared. And today, we can stay underwater even longer thanks to enriched air. Enriched air, sometimes called nitrox, extends no-stop limits, and when coupled with an enriched air dive computer, provides more dive time than ever before. Enriched air is most useful in the 18-metre 60-foot to 30-metre 100-foot depth range, because in this range, the dive often ends because you run out of no decompression time. And you'll find enriched air really boosts your bottom time when you make repetitive dives. The PADI Enriched Air Diver course qualifies you to use enriched air nitrox. You'll learn its benefits and drawbacks, special equipment considerations, the procedures for obtaining and analyzing enriched air, how to use enriched air computers and dive tables to plan dives, and how to effectively manage some of the possible risks associated with it. What exactly is enriched air nitrox? As you may recall, air consists of 21% oxygen and 79% nitrogen. Enriched air has been enriched with oxygen, so that it has more than 21%. Enriched air 36, for example, is 36% oxygen. As a recreational diver, you'll typically use enriched air that has between 22 and 40% oxygen. Most of what you learn in this course relates directly or indirectly to this added oxygen. The primary purpose of enriched air is to extend your no-stop dive time. As you recall, it's nitrogen dissolving into your body tissues that determines the no decompression limits. Enriched air replaces some of the nitrogen with oxygen, and your body metabolizes and absorbs oxygen. Since you're breathing less nitrogen, you can stay down longer, all else being the same, compared to the same diver using regular air. How much more no-stop bottom time you get depends upon your depth and the amount of oxygen in your enriched air blend. In the 15-metre 50-foot to 27-metre 90-foot range, the additional time can be substantial, especially on repetitive dives. When you use enriched air with an enriched air dive computer, your no-stop time is so long that you're more likely to be limited by your gas consumption than by reaching a no decompression limit. Sometimes divers wonder whether the no-stop limits for enriched air are as reliable as for air, and the answer is yes. Decades of tests and field experience with hundreds of thousands of dives by military, scientific, and recreational divers has established an excellent safety record for no-stop diving with enriched air. Sometimes divers wonder whether enriched air might have a safety advantage over air, or if it causes less narcosis. Diving well within air no-stop limits, there's probably no meaningful safety gain by using enriched air nitrox. And since oxygen has similar narcotic properties to nitrogen, plan your dive taking narcosis into account, just as you would with air. Enriched air does have 5 considerations you don't have diving with air within recreational limits. First, there's a potential for oxygen toxicity. This is the most serious of the potential hazards unique to enriched air diving. Second, you'll have a few special equipment considerations. Third, enriched air isn't as readily available as air. And fourth, enriched air requires special blending and handling protocols. Finally, you'll find that planning an enriched air dive takes a few more steps than an air dive, and there's a bit more error potential, though it's not particularly difficult. The primary concern about enriched air and your equipment is the high oxygen content in enriched air. In the presence of high oxygen, many materials will burn or explode that wouldn't otherwise. High oxygen can also make equipment deteriorate more rapidly over time. However, with enriched air that has no more than 40% oxygen, the community guideline is that you can use the same regulator, BCD, and other equipment that you use for air except for your cylinder. We'll look at cylinders in a moment. However, manufacturers, local laws and regulations, and local practices may require special equipment modifications for enriched air. A few manufacturers say not to use their equipment with enriched air at all. Follow the requirements that apply to your gear and your local area. Unlike your other equipment, enriched air diving requires a dedicated cylinder for 2 reasons. The first is that it must be clearly marked so no one accidentally dives with enriched air thinking it's air. The second is that one method of making enriched air involves putting pure oxygen in the cylinder. For safety, a cylinder used for blending gases this way needs to be specially cleaned and lubricated, even if the final blend will have less than 40% oxygen. Typically, an enriched air cylinder has a distinct color or band to clearly identify it. This type is the most common, but local regulations may stipulate other color coding. The cylinder will have a content sticker or tag that shows what enriched air is in it, a decal showing whether the cylinder meets oxygen service requirements, and an inspection sticker like you find on any other scuba cylinder. Filling your cylinder has some concerns too. The first is that high oxygen content can present a fire explosion hazard. And the second is that to dive it safely, you need to be certain of the percentage of oxygen in your enriched air. To manage these concerns, always have enriched air cylinders filled at a proper enriched air station by a qualified enriched air blender. Certified gas blenders have the special training and blending equipment necessary to avoid possible hazards related to oxygen. And they know how to blend accurately so you get the enriched air mix you want. This is especially important for enriched air cylinders that must meet oxygen service requirements for blending. Conventional air-fill systems may contaminate a cylinder with trace lubricants that are harmless with air but create a fire risk with oxygen. All gases put in the cylinder, including air, must be oxygen compatible. If an oxygen service rated cylinder is accidentally filled from any source that doesn't provide oxygen compatible gas or air, you need to have it reserviced before it can come in contact with any gas with more than 40% oxygen. This is why you would never put pure oxygen in a scuba cylinder and have it filled from a conventional air station in an attempt to make enriched air. Doing so poses a significant fire or explosion risk. Reputable blenders are trained and certified to avoid these problems. Look for the DSAT Gas Blender certification or other credentials showing training in gas blending. If you're interested in learning to blend enriched air nitrox, ask your PADI instructor, dive center, or resort about the DSAT Gas Blender course. Diving air within recreational limits, your oxygen exposure isn't an issue. With enriched air's higher content, it is. As an enriched air diver, you need to stay within accepted oxygen limits and track your exposure, much as you do with nitrogen. You measure your oxygen exposure based on the oxygen partial pressure, which refers to the pressure exerted by just the oxygen in your enriched air. Find this by multiplying the oxygen percentage times the absolute pressure at depth in atmosphere or bar. For example, suppose you dive at 10 meters or 33 feet using enriched air 40. As you recall, at 10 meters 33 feet, the pressure is 2 atmospheres, one of air and one of water. 40% oxygen times 2 atmospheres equals 0.8 atmospheres of oxygen partial pressure. When working with percents, remember to use the decimal form, 0.40 in this example. Oxygen partial pressure will vary with your depth and the blend. Your oxygen partial pressure is 0.80 atmospheres absolute at 10 meters 33 feet, but with enriched air 36, you reach 0.80 atmospheres absolute at 12 meters 40 feet. Your oxygen exposure is the same. Oxygen limits are therefore independent of depth. The maximum oxygen partial pressure is 1.4 atmospheres absolute. You will learn to plan your dives so you don't exceed the blend's maximum depth, which is the depth it reaches 1.4 oxygen partial pressure. This is the accepted dive community standard, with a partial pressure of 1.6 atmospheres absolute, used as a contingency depth for planning purposes. You want to dive conservatively, well within the limits. Planning your dives so you remain well above the maximum depth where your blend reaches 1.4 oxygen partial pressure gives you room for error and an added margin of safety. By staying well within limits, you minimize the most serious risk in enriched air diving, oxygen toxicity. Exceeding 1.4 atmospheres absolute, partial pressure can cause central nervous system toxicity, which can manifest itself as a convulsion. While a convulsion isn't usually directly harmful, underwater, a diver is almost certain to lose his regulator and drown. Warning signs and symptoms may precede a convulsion, but usually they don't. If they do occur, they include visual disturbances, ears ringing, nausea, twitching or muscle spasms, especially in the face, irritability or anxiety, and dizziness. You can remember these by remembering vented. If you experience any of these symptoms, ascend and end the dive immediately. Heavy exertion, some drugs, and carbon dioxide retention may predispose a diver to oxygen toxicity. Avoid overexertion and breathe normally. Consult a physician knowledgeable in diving with respect to prescription medications before diving with them. Within the limits, Enriched air diving has an excellent safety record, but ignoring the limits can be life-threatening. Remember, it's very easy to manage oxygen exposure simply by staying well within accepted limits. In Section 2, you'll learn more about tracking oxygen exposure, but for now, realize that not exceeding an oxygen partial pressure of 1.4 is the most important precaution you need to follow. By now, you realize that to plan your dives, you need to know the oxygen percentage of the enriched air you use. You use your oxygen percentage to set enriched air dive computers, to determine your no-stop limits, and to manage your oxygen exposure. Gas blenders analyze enriched air after mixing it using an oxygen analyzer. Nonetheless, you personally analyze the gas yourself, or in some cases, you watch someone analyze it while you personally confirm the analysis. Do not dive an enriched air cylinder unless you've personally verified the contents. There are no exceptions. Although errors are rare, this is an important double check of the initial analysis and that the cylinder's been marked correctly. Never forget that if there's an error, the person who can get hurt is the diver, you. Just as important, once you confirm the gas analysis, keep your cylinder somewhere that it won't accidentally be used by someone else or create any question about what's in it. If there's ever any doubt, reanalyze it. It's a good practice to reanalyze just before a dive in any case. Let's review the procedures for analyzing enriched air. You can use one of the many analyzers currently available to divers. Begin by turning it on and calibrating it. You usually do this by flowing air through the analyzer with a flow restrictor or other flow control device. Some of these connect your regulator's low pressure hose. Others attach directly to the valve. Use a slow controlled flow and set the analyzer for air, usually 20.8 to 21% oxygen, depending on the analyzer. After calibrating, leave the analyzer on and flow enriched air through it at about the same rate. Allow the reading to stabilize and read the oxygen percentage off the display. You can calibrate some analyzers using the air in the room, but don't do this in high humidity or when you've been analyzing a lot of cylinders, because these can affect the calibration. Your best bet is to calibrate with a cylinder of compressed air. Analyzers are reliable, but if there's ever any doubt, compare the one you're using with another. Your readings should be within less than 1% of each other. After analyzing, compare your analysis with the cylinder contents sticker or tag. Minor variations between the blender's analysis and yours are normal. But if you've already planned your dive and the blend is off by more than 1%, you need to recalculate your maximum depth and no stop limits if using tables, or reset an enriched air dive computer if you already set it. Most enriched air computers and tables use 1% increments, so round fractions to the closest whole percent.